Now, Marcel, welcome. This is
Hello.
Future Talk, CeBIT 2014. Welcome here. Welcome, Marcel.
Thanks for the introduction. Thank you. Okay, so I will give an overview in more depth what Philip just showed as a general concept and give some examples as well. So just to mention ahead, we have a lot of partners working on this. So that's not just from us, but also from all the partners you can see on the top right. Okay, so you have seen this already. So this is the three-tiered structure we have for testing our games and to categorize. And so what is already possible nowadays is tracking like a flat marker, like an image marker, and we are hoping to extend this in the future also to track 3D objects like toys, for example, as you can see on the left image, and also maybe even later on as a citywide experience, you can maybe use it outside for outdoor tracking, and maybe there's a new type of games which is possible with those applications. So, but I can show some examples what we already did. So this is, you can see here a large balloon floating through a conference hall, and people could download an app on their smartphone using one of our technologies, which is the fast feature tracking. And we had over 1,500 users testing this, and I will show you a video how this actually looked like. So you can see there's this is a static camera now which is used. I will go a bit forward maybe. So now you can play such games on your smartphone, and even if you change the view of the device, which is not shown here, but you can it is still tracked, and this is a very easy thing because it's just tracking one colored blob, and this worked well for this balloon setting we had. So actually you could shoot on those red objects, for example. Oh, okay. So this is another application which is realized with a reality mixer, in particular the reflection mapping enabler. So what you can see here is a movie theater where the visitors can snap a picture of themselves with the main characters, for example this grizzly bear, and so they can stand next to next to the poster in the background, and the bear is rendered on top of the image. So if you stand correctly, so if you're not allowed to cover the bear, but otherwise it works great. And you can also see, for example, the shadow below the person and the shadow below the bear look quite similar. So that's what these spheres are used on the side of the poster. I may be able to show it. So you can see this white sphere and this reflective sphere, and those are used to capture the actual image, and the real lighting situation is used, and this means the bear looks really as it would be standing there. So if there was some red light coming from the right side, then you would also see the red light being shown on the bear. So I think this is actually being developed to a commercial application. Probably there's a free download, and maybe you can see this very soon in your movie theater with your and pose next to your hero character. Who knows? So then there is a great game developed by Disney Research, and actually this game you can also see on the demo table just on the other side, right here on the tables, and you can try it yourself. So what you can see is also this reflective sphere again, where the lighting condition is used from the real room to illuminate the virtual objects. so that it looks more realistic. So the idea of the game is a tower defense game that many of you may know. So you place virtual characters on the game surface, and you can see characters walking over the table. Yeah, they are shooting the units actually. Okay, so once again, you're happy to try it out yourself. It's running right now on one of those tables over there. So one common technology also needed for games is a leaderboard. So this is connected to a server, and we made a very easy component, so it's very easy to integrate for game developers, and not every game developer has to reproduce this functionality, and it can be used and viewed on the web page, for example. So we also have a demo also on this table over there, which is a networked synchronized virtual character. So the idea is that maybe on those mobile devices which are not very powerful yet, maybe there is some physical simulation that you want to run, which is too heavy, too computationally expensive. So you can run this simulation on the server and connect multiple mobile devices to this, and maybe just show the result, maybe a water surface. So you can send the actual surface data to the mobile devices, but you can do all the volume physics simulation on the server. So this is one example where you can control the spider. I think, don't have a video there, but you're also invited to just try it out yourself. So this is another application again. Here it's controlled with a Kinect. So you can see the depth image on the bottom right. So there's someone flapping with the arms, which is a fun experience in itself. And you can, if you lean forward and backward, you can control how the dragon goes up and down. So you just fly around this landscape. I'm not sure how actually the fire is controlled. So, and the idea is maybe to also connect other devices, so you can maybe place some targets on a second device, and then multiple players can join this game, for example. Of course, you always have to select coins which are floating mid-air. This is just game logic. Okay, so to make things look more realistic, we have this reality mixer. And one part I already showed to you is the lighting probe with a sphere, which is a very fast and easy way to integrate the actual lighting. Another issue might arise if you look at motion blurred images on the left side. You can see that the actual camera image looks very blurry. And if you now render a very a not blurry image, like a normal virtual image on top, it doesn't really fit into this image. It sticks out. It doesn't look as if it was really belonging to this scene. So what we try to do is to actually add a motion blur to the virtual rendered objects according to the actual motion, and then it looks something more like to the right. And this is a single screenshot. It's not perfect yet, but it's showing the idea how to realize this. So seeing this in a moving image, you wouldn't really notice a strong difference. So what we do here is not actually analyzing the image, but using the gyroscopes and accelerometers on the device to get this effect with very low computational power. Okay, most of the specific enablers from this game platform I demonstrated now, and there's some more. You're welcome to just look at the website, mediafi.org, and browse through them. There's also demo code online showing simple usage. Some of it is JavaScript, some other parts are in Unity. There's REST interfaces and APIs are available, which are open anyway, and most of the enablers are open source with the MIT license, so you can use it for whatever you like. And yeah, just check it out. There's most source code is available on GitHub, so you can, and you're invited to actually contribute and modify and improve the software. It's our job is really to just start it off, and hopefully you will also work on this. We also validated our enablers, so we wanted to test them out, and we had a few hackathons going on. So the last one was 2 weeks ago, and we had 30 students coming over, and even some professional game developers to create a game using the template games and provider technology. And they had only 10 hours time approximately. And I have a video here, so I can just show you some of the best results, what they came up with just within 1 day. So this is not playing. So this is one physics simulation which is running on the iPhone, and this is a soccer game where multiple players can control this character. This is one of the assets. You can recognize them from the other games. So now this is some virtual pet, which is similar to the Tamagotchi idea, maybe, where you can feed the cat when it's hungry, or when it's sad, you have to play with it. And then, so this is a block stacking game where you have to get as many blocks from the float on your own boat. And this is a very similar idea where you have to stack as high as you can, and the maximum height of this pile is then scored. Okay. So there's one upcoming hackathon on Saturday in Barcelona. So there's more students working on this, hopefully. And if you happen to be in Barcelona, you're welcome to join the hackathon as well. And there's also an online competition. So the idea, the problem, of course, with a very short time frame is that there's not much you can do. So there's this online competition which is running about 3 months. So the deadline is in June, and you're also very welcome to participate in this hackathon, which is now online on should be very soon on our website as well. So it just started yesterday actually. So it's all good. You can still participate. Okay. So for the upcoming year of the project, we are looking into citywide gaming. So we try to to come up with some sample games where we can use the technologies that are existing and that are just coming from research as well, to be able to play this not in your living room, but really play it outside, maybe from one bus stop to the next bus stop, maybe during going to school or to work, or maybe using some 3D tracking, which hopefully comes with new partners joining very soon. So we can maybe use SLAM technologies for creating a map and scanning this with your mobile device, and then maybe linking several devices, so you can see maybe in a pedestrian zone you can have virtual graffiti applications or something, so that people can spray something on the wall, but virtually only, so nobody will arrest you for this, hopefully. So and everybody can share this and rate this, for example. Okay, so this was it. I have to mention that we use Unity and XML 3D as the basic technologies for the gaming, and also the tracking that we use with Unity is from Qualcomm, which is called Vuforia, so it's working great. And since it's already existing, we use it. It's very convenient to try out. On the right, you can see all the partners which are connected to the future internet content platform. Okay, thank you so much, and maybe you have some questions for the gaming platform. So do we need a microphone? Oh, okay. Maybe I'm too quick. Was I too quick? No. Any questions for the gaming platform?
All right, so who's the one with the first question? And then I'll find someone for the second question. Okay.
For what aspect are you using Vuforia? Because I understood from the previous presenter that you are not using this kind of platforms.
Oh, so we use both. No, it's a good question. So we use both, especially for actually since it's still very hardware intensive. We also have native apps running, so we do use Unity to deploy to several devices. But of course, in future, maybe we can even do it in the browser. But at the moment, we also use Unity to push the limits and see what's going on.
Oh, just a second.
Sorry, and for the Vuforia part, the Qualcomm part, are you using their augmented reality browser or?
No, we're using a plugin for Unity, which is doing the image tracking at the moment, and hopefully maybe we can get some 3D tracking soon as well.
Okay.